address. But here in the input transaction, you see much more complicated thing. For example, this says prev out, and then it says Coinbase. Okay. On the other hand, there's no clear Bitcoin address here. Okay, there's actually not Bitcoin address here that you can see clearly here. So what it is actually is that every block is connected to the previous block. Okay, so the Bitcoin that's being spent in this transaction. Okay, so here, for example, you want to send some Bitcoin. For example, in this transaction, the amount of Bitcoin that's being sent is 25.233888795 Bitcoin. Okay, so these value, that means in your input Bitcoin address, you need to first have this amount of Bitcoin. So you need to have a Bitcoin address which already holds this amount of Bitcoin. That means, what does it mean? That means in a previous transaction, somebody should send that much of Bitcoin to that specific Bitcoin address that you are now going to use as the input Bitcoin address. That makes sense? Okay, so that means in a previous transaction, this Bitcoin address, the Bitcoin address that you are going to use as the input Bitcoin address in this transaction uh, is has already been used as an output Bitcoin address in a previous Bitcoin transaction. So that previous Bitcoin transaction should also have a hash ID, right? So this actually represents to that. So basically, you are linking your Bitcoin address. You are linking to a previous output of a previous transaction. Okay, and as you can see, for example, I can give you an example. For example, this Bitcoin address, this 1khmsyt, this Bitcoin address has 2.9698218 Bitcoin. Okay, for example, this is your Bitcoin address. Okay, so for example, this is the Bitcoin block 358992. For example, in Bitcoin block 368992, you want to spend that Bitcoin from that specific address. So what you will have to do, what you will have to do, what you'll have to do is to make this transaction where you put the hash, you put the hash value. This is the transaction hash. So you'll have to find out this transaction hash value, and you'll have to put the transaction hash value in this prev out. And what this n means is the nth transaction. So this is the Bitcoin block. So this is the first transaction, this is the second transaction, this is the third transaction. That means, so in total this has 1247 transactions. So this n actually refers to the position of the transaction in the Bitcoin block. Okay, that means, so in so okay, so this transaction is actually a special transaction. I'll describe it later. So all the transaction, as I just described about the structure of the transaction, that means every transaction needs to have this initial part, then it will have two separate parts. One is the input, and another one is the output. In the input part, what you'll have to do, you'll have to give the hash ID of a previous output, and the position of the transaction. Okay, and what this script sig means, that when you, for example, when you are writing a check when you're writing a check to somebody to give him some money, you need to give your signature. So same kind of much more same kind of digital signature is involved in Bitcoin transaction. That actually is going to be for which this script signature is required. So Bitcoin uses is a non-Turing complete. I mean, not. I mean, Bitcoin uses a script programming language, and that we'll describe later. So that is so this is the script signature. Okay, and this signature, what it basically means is that, for example, the previous everybody can see this transaction. For example, I can also you are seeing this transaction. Anyone can see this transaction, but nobody can sign the transaction. Okay, only the person. When you have a Bitcoin address, we'll talk about public key cryptography. So in a public key cryptography, so I haven't yet talked about Bitcoin address. So when we have a Bitcoin address, so basically it's a public key, and for each public key we have a private key. Okay, and when I'll talk about the public key cryptography, we'll talk deeply about it. So the person who are capable of creating this script signature is the person who not only have this public key hash of the Bitcoin address, but also have the private key of it. Only a single person or single entity have the private key. That's why only that person can create this script signature. Okay, so that's how Bitcoin creates. That's how actually Bitcoin incorporates the cryptographic security. Okay, and on the other hand, this output part, which has actually says that okay, you are sent from this previous output, and that means from a previous input address, you are sending 20.9273950 Bitcoin to whom? To this Bitcoin address, to somebody else's Bitcoin, or it can be your Bitcoin address too. For example, you can just send yourself some Bitcoin. So as you can see, so this Bitcoin address is going to have this much of Bitcoin from these from the address of the previous transaction, which is identified by this hash transaction hash ID. Okay, so as you can see, the script pub key here also you can see some programming that is in Bitcoin we call it opcode, that means operation. So basically this has meaning. I'll later there's another article in Bitcoin wiki that is I think called is script. So yeah, in this script, as you can see, here are constants. So these are the opcodes of Bitcoin. We'll talk about it later. So these opcodes are written in this script pubkey. Okay, but however, what it basically does, we'll talk later. So this dupe means duplicate, and this is hash 160, and it hashes and it verifies. It basically verifies. So this Bitcoin address receives this around 20 Bitcoin address. So what happens is basically this person, when he will the entity or the person who is receiving the Bitcoin in this Bitcoin address, when he will try to make a future transaction, this script pubkey, this opcode will 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 help him to create another script signature to send to send some fraction of the Bitcoin address or address from these amount of Bitcoin using this script using the opcores of this script pubkey. However, so we have seen the structure of the Bitcoin block. We have seen Bitcoin header today, and we have seen Bitcoin transactions. And today, probably the whole thing that I have shown, the people who are watching this for the first time, it may be complicated for you, but at least you got the idea about the main components of Bitcoin, and definitely I will talk in detail about how these script SIG and script pub key basically works, and what each of the constant means. So today I will finish it here. So another last thing that I should have said is that as you have probably already noticed that when I was talking about this first transaction, you have this extra thing called Coinbase, and you have this hash code 0, and this n is really large. On the other hand, this looks like much more what I say. This is a hash ID, bunch of string with different characters, and the n is small. The first transaction of the previous the first transaction, and uh, oh, I think I have made a mistake. I think I have when I told that when I told this is not the so in the input part, in the prev out, this is not the transaction hash ID. It's basically the block hash ID. So in the previous output, this is actually this is actually the hash ID of the block in which the first transaction. Okay, so basically what it means, go to this specific block, look at the first transaction, and take all the input addresses of the output section of that transaction. I mean all the output addresses of the first transaction, and use those output addresses as the input of this transaction, and use my private key to create this script signature, and give that amount of Bitcoin to this Bitcoin address, and create this script pub key, this opcode, so that this person or this entity can in future make another transaction from these, by using this transaction as the